Hey guys, welcome back to my channel. 今天想给大家分享一个人生真谛 through a time series regression model. OK， 因为每次在我的网课上讲到这个 topic 的时候，大家都会觉得，原来这个特别简单的 time series autoregressive model 居然能够让大家看到人生的真谛。OK， 就今天就把这个分享给大家。这个 model 就是 first order autoregressive regression model or first order autoregressive process， 是一个一阶自相关模型。OK， 是一个最简单的一个 time series regression model。接下来我会持续的把我对 time series econometrics analysis 的一些心得和体会发到这里。希望大家会觉得 helpful。OK。So I want to use autoregressive process with order 1, first order autoregressive process 去解释一下 live in the moment, 活在当下。Okay, without further ado, let's get into it.
Okay, let's look at the AR model that's autoregressive with order 1. Okay, or you can call this autoregressive process with order 1 or first order autoregressive process. So AR with order 1. The model looks like YT rho. That's usually the symbol we use to denote a coefficient of autoregressive process or autoregressive models. YT minus 1 and plus epsilon t. So you can understand this as the value y in year t depends on the value y in the previous year and plus a current random shock. You can also understand this as 这个人在 t 年的时候会发生什么，取决于这个人在之前一年发生什么。当然，它有一个影响系数，which is here, rho is a coefficient, plus 当前就当下你经历了一个 unexpected shock. This could be COVID 或者是macroeconomic shock， 比如说一下子 financial crisis， 或者这个人突然间生了一场病在当下，或者这个人突然间有一个小事故，或者这一年突然结婚了，突然生孩子了，遇到什么好事了 get promotion， 所以就是当下的一些 unexpected shock， 所以我们可以把它理解成一个 random shock, unexpected shock or idiosyncratic， 就是个 random shock, idiosyncratic shock， 就当下的 unexpected shock。 And this could be a coefficient， 它是一个常数，你可以用 OLS to get the coefficient of rho。 你有一系列的 y 值，对吧？然后一系列的 yt minus 1， 这是个 time series 的一个 model。 因为 yt only depends on the value y in the year t minus 1, so we call this first order autoregressive process， 就是自相关或者自回归模型。And then we can talk about ARP with pth order autoregressive process in future videos and also MA model. Okay, but here today we focus on AR model. So let's see how we can understand this model. Usually we do the recursive process, right? So we do this, yt equals rho, and here you have t minus 1, but we can do the iterative process or recursive process. So we know that yt minus 1 equals rho times yt minus 2 plus the current year, which is epsilon t minus 1's random shock. We can add there rho yt minus 2 plus epsilon sub t minus 1. You know this is just a yt minus 1, right? You know this. And then plus epsilon t. And then you can do this rho squared yt minus 2 plus rho epsilon t minus 1 plus epsilon t. And then rho squared, do the same. Yt minus 2, plug back in here. If t equals t minus 2, this will be rho y sub t minus 3, right? So you can do this. Rho y sub t minus 3 plus epsilon t minus 2. That's yt minus 2 and plus the rho previous year's unexpected shock plus current year's unexpected shock. Okay, and by the way, you should know that ET supposed to be a white noise, that's IID with mean zero standard deviation constant. Okay, that's white noise. We'll talk more about that in the future videos, but today just focus on AR1 process. So that equals rho cubed yt minus 3 plus rho squared epsilon t minus 2 plus rho epsilon t minus 1 plus epsilon t. Okay, you can do all the way down. So rho cubed, and then you have yt minus 3, yt minus 4 plus epsilon t minus 3, right? And plus rho squared epsilon t minus 2 plus rho epsilon t minus 1 plus epsilon t. Right, that equals rho to the power of 4 yt minus 4 plus rho to the power of 3 epsilon t minus 3 rho squared epsilon sub t minus 2 plus rho epsilon t minus 1 plus epsilon t. Okay, I can do the same, and you can imagine that the last term will be rho to the power of t, and y sub t minus t will be 0. So that's the first value of y, or the value of y in the first year or first period of time, or the initial value of y, plus rho to the power of t minus 1, and this epsilon subscript will be t minus 1, which is 1, right? Plus rho to the power t minus 2 epsilon 2 plus rho to the power t minus 3 epsilon 3 plus all the way to rho to the power of 1 epsilon sub t minus 1 and plus rho to the power of 0 epsilon t minus 0, which is t. And now you just look at this yt. You can understand this as 这个人在第 t 年的时候的状态 depends on 他在最初的状态，当然有一个影响系数 which is rho to the power of t， 然后再加上 look at this, we know that these all shocks, right? These all shocks, so that's all unexpected shocks in the every current period. This is actually a weighted average of all the historical shocks or all the historical unexpected shocks. We can simplify this as rho to the t y0, this yt, plus sum I from 0 to t minus 1, and rho to the power of I epsilon t minus I, right? 这个就是一个加权平均 weighted average of all the historical shocks. 就当下经历的每一个unexpected shocks 一个加权平均 coefficient gave us the weight of each shock, and this is the initial value of y. 活在每一个当下 you can understand this as this initial value of y 可以理解成一个原生家庭的一个状态 right? So 原生家庭是什么样子的，或者 initial status 是什么样子的 and don't forget this is a rho to the power of t, which is a influence coefficient. How does initial status affect your current status? The influence coefficient is measured by rho t, and actually this gives us the effect of the initial value of y on current value of y. 就你最初的原生家庭会对你现在状态造成什么样的影响，这个影响 is measured by rho to the power of t. Okay, and later videos I'll talk about the stationary process, the stationary time series process. 你会发现 stationary 就是平稳的。If you want an AR model to be a stationary process or a stationary time series process, you need this condition. If rho is a fraction between 0 and 1, and if t is large enough, you will understand this, right? Approaches 0. When t approaches a very large number. 也就是说原生家庭对你现在的状态影响是非常小的 Initial value of y will have an insignificant impact on the current value of y. This is not negligible. 就你不能忽略到这些东西。也就是说你每一个当下的 shock, right? In my previous video I talked about that. handle 好当下的每一个 shock。你当下的每一个 shock 都会影响你现在的状态，你当初每一个当下 right? So this is the first unexpected shock you experienced epsilon 1，但是它的影响系数 just rho to the power t minus 1. If t is a greater value and rho is, a fraction, and then this will be small. This is the second unexpected shock experienced. It also has a coefficient, right? How would the second unexpected shock affect your current status? It's measured by this. Again, if rho is between 0 and 1, and t is a relatively large number, and there could be also small effect. And now look at how the current unexpected shock affects your YT. This effect of current unexpected shock on YT is measured by this rho to the power 0, which is rho, which is largest, right, compared to any other previous shock. So the current value of Y depends on the initial values of Y and all the unexpected shocks you experienced. 所以就是说 AR1 process, 我们 assume this is stationary. We talk more about stationary later because this is a very, very useful concept. If the absolute value of rho less than 1, we say the AR1 process is stationary in variance. Okay. If the y0 is 0, you can always make the first value y0, just yt, each value minus y0. And then this AR1 process is stationary and mean, right? Stationary and mean invariance. So if this is true, that means there is a very insignificant impact or effect of the initial value of y on the current value of y. And the value of y is heavily dependent on the weighted average of all the historical unexpected shocks. What I want to say is if we think of life as a trajectory, where you are right now definitely depends on where you started. But more importantly, if you've been living a relatively stable or stationary or predictable life, your current state is mostly shaped by how you handle unexpected shocks along the way. So at the end of the day, all we really need to do is focus on living in the present. Living in the present. Handle 好每一个 unexpected shock. Handle 好每一个当下的 unexpected shock. Okay? I say this to myself. Did that make sense? 活在当下 live in the present, live in the moment. Okay, 如果你现在吃饭就好好吃饭，如果现在睡觉好好睡觉 easier said than done. 好难 especially when you have some unexpected shock, 对吧？所以again 理论还是理论，实践起来还是很难的。So 如果你想要有很好的未来，你只需要把当下的每一个 shock handle 好，共勉吧。Hope you find this helpful and see you next time. Bye.